Welcome. So in this part of the video, we're going to be working through this question right here, which is going to be similar to what we saw previously. So let's zoom in here and let's read it. It says, find a sequence of transformations that takes this right here to the graph this. So as we previously saw, we're starting with a graph that looks like it has already had transformations applied to it, and we're going to try to get rid of them to get here. Now, of course, that statement can be challenged because everything's relative. Who's to say, what's transformed to start with? But for our simple minds, we're going to say that, this looks like it's already had things transformed to it. So we're going to be doing the reverse transformations in order to make it look like that. Okay, so with that introduction, let's get started. And we're going to begin by doing it by inspection. So write by inspection. Now, when you've got questions like this, I would actually recommend not doing them by inspection because it can kind of do your head in a little bit, and doing it by the method is actually beneficial to make sure you don't get yourself tied up into knots. And as we're going through by inspection, you'll be seeing that occur. Also, what makes this a little bit trickier as well is the question of, should I factorize when I do it by inspection? Normally, like when you've got a normal question, always factorize. But when we're in this situation here, one could make the argument that maybe we don't factorize. And I'll be showing you the alternatives. So what I want you to do is I want you to split your page up. And on one side, we're going to factorize. And on the other side, we are not going to factorize. And you're going to be seeing which is easier. But remember, I wouldn't even recommend you do it by inspection to begin with, because it's just going to get a bit confusing. It's going to get quite confusing very quickly. All right, so if we were going to factorize it, we would start by writing out the factorized form. So I'm going to take out 5 here, and I'm going to be left with this. Now, what we're going to do is the reverse transformations to make it look like this. If we've factorized it, what we're kind of saying is, hey, do the translations first, right? Because I immediately look at this and say the first thing that I can do is get rid of this -1 on 5. Now, this -1 on 5 is telling me to move it 1 on 5 units in the positive x direction. So to undo that, I'm going to be moving it 1 on 5 in the negative x direction. So translate 1 on 5 units in the negative x direction. So I'm doing the opposite to what I see there, just as we did in the previous example. So that means I'm like plussing 1 on 5 here to get rid of that. And remember, do all your translations at once. I'm also going to move it 6 down. So, and 6 units in the negative y direction. Perfect. Once I've done that, so now I have dealt with my translations, then I'm going to deal, that's an ugly n, let's try that again. Then I'm going to deal with this 5 here. Now this is where it can get confusing a little bit, and why I recommend you do it by the method instead of doing it by inspection. What's this 5 doing? This 5 is causing a dilation of 1 on 5 from the y-axis. So if I want to undo that, I'm going to have to perform a dilation by a factor of 5 from the y-axis, right? So I'm going to go then dilate by a factor of 5 from the y-axis. Now that right there might throw people for a loop. Some people might go, oh, that's pretty easy. But remember, it's sometimes easier to do it by the method, just so you don't get tripped up by that. When I say dilate by a factor of 5 from the y-axis, if I was to apply that, that means I'm taking this x and I'm replacing it with x on 5, right? And if I've got x on 5, that 5 cancels with that 5, and then I've just left myself with x squared, and that's what I need. I've just got that x there. It's probably a bit messy there, but hopefully what I've said has made sense of that. So if I was just to highlight here, I first translated, and then after I translated, I dilated. Now, alternatively, you could do this without factorizing. What would that look like? So I come over here, and I'm just going to write it as I see it here. If I was to do it this way, the first thing that is affecting my x is this dilation. So that means the first thing that I would do is dilate. Now I'm actually going to write this a bit bigger. Okay, so as I said, the first thing that's happening this time the first thing that was happening was this translation. But now, as you can see, the first thing that's happening to this x is this being multiplied by 5. So if I want to undo that, what I'm going to have to do is dilate by a factor of 5 from the y-axis. And remember, the reason why that works is because when I dilate by a factor of 5 from the y-axis, what that means is I'm taking this x and I'm turning it into that, right? And now that 5 cancels with that 5. So I've gotten rid of that 5, and that was the whole point. Then I'm going to deal with my translations. As you can see, what's happening is that I have a translation of 1 unit in the positive x direction. So to get rid of that, I'm then going to do translate 1 unit in the negative, because I'm doing the opposite, right? So let me just repeat that. I'm very afraid that I'm going to say the wrong word. So what's originally happening here is that I'm moving it 1 unit in the positive x direction. So to undo that, I go 1 unit in the negative x direction. So I'm plussing 1 there. And then I need to get rid of that 6. That's the easy one. And 6 units in the negative y direction. All right, both of these answers are correct. They're just approaching them in different ways. And the question of whether or not you factorize is important. So here I dilated first, and then I translate. Translate 1 unit in the negative x direction and 6 units in the negative y direction. Okay, that's the first way to do it. I'm almost tempted to pause it here and then start a second video for the next part. Let's be brave. And let's just do it all at once. We're now going to do by the method. Let's hope I don't say anything or do anything wrong here. By the method. When recording these videos, because the language is so precise, they're very difficult to record because I have to be so precise in what I'm saying. Okay, so if we're doing it by the method, we're starting here, and I'm then going here, like that. You then have to be careful about what direction you're moving in. So remember, this is our transformed graph. So I put y equals x squared here, and I put my dashes there. And then on the left-hand side, I have y is equal to, now let's just double check this for a second. Yeah. On this side, I have 5x minus 1 squared plus 6, like that. Okay, so that's what we have to start with. I'm so paranoid, I'm just going to check one more time. Yeah, that's correct. The next thing that I do is I rearrange this. So I'm going to get y minus 6 is equal to 5x minus 1 squared. And then on this side, I have y dash is equal to x dash squared. Perfect. Then the next thing that I do is I equate. So this is equated with that. And then this is equated with that. So I have y dash is equal to y minus 6. And x dash is equal to 5x minus 1. And now we have that issue again. So there are now two ways of doing this. So I'm going to show you both ways, just so you have a very complete picture. I could just show you one way, but then I would feel like I'm cheating you of enjoying this. So let's go alternative 1 and alternative 2. And that way you can fully appreciate what's going on. Let's start on this side first. So we have x, y, and we're going to x dash, y dash, x, y. I know that x dash is 5x minus 1, and I know that y dash is y minus 6. Okay, this is where we need to be careful. What is first happening to my x? Is it being translated first, or is it being dilated first? It is being dilated first. As you can see, it's 5 times x, then I subtract the 1. So that means I first deal with the dilation first. So if I was to write this out, I would say first dilate by a factor of 5 from the y-axis, then translate. And now it's just a matter of reading off what we have here. We're translating 1 unit in the negative x direction, and 6 units in the negative y direction. Let's scroll down. Perfect. Let me just tidy this up a bit. Keep going down. So as you can see, this corresponded with translate 1 unit in the negative x direction, so that, and 6 units in the negative y direction, that. But before I did that, I dilate by a factor of 5 from the y-axis. So you can see I'm just reading it straight off that, and doing it by this method corresponds to what we saw up here. This is the same thing. That is the same as that. Perfect. And as you can see, doing it by the method, you're just a bit more secure in what you're doing, at least in my opinion. Doing it by inspection leaves some room for error sometimes. You're more likely to make a mistake maybe. The other way to do it, so once you figure out what x dash is, there's of course another way to write it. So you could write it like this. I have x, y, and I'm going to x dash, y dash. And instead of writing x dash like this, I could factorize it. I could take 5 out, and that would leave me with x minus 1 on 5. And then on this side, then for y dash is just y minus 6. So what's really important here is for you to realize is by factorizing, this is different to that. And that changes the sequence of the transformation. The sequence changes. Okay, let's now write our answer. So what you need to realize is here, what is the first thing that happens to my x? Is it dilated or is it translated? Well, because of the brackets, it's translated first. So the way that you'd read this is, I first translate 1 on 5 units in the negative x direction. And then remember, read off all your translations at once, and then 6 units in the negative y direction. Then, after we've done that, we then dilate by a factor of 5 from the y-axis. and we're done. So if we just come here for a minute and just reflect on what we did here, my voice is about to give up. We first translated, because that's what we had to do, because we factorized, that's what we had to do. So translate 1 on 5 units in the negative x direction, and then remember you have to do all your translations at once, 6 units in the negative y direction, and then once we translated, then we dilated, then dilate by a factor of 5 from the y-axis. And this is the same as what we did here. Hopefully that makes sense. It is confusing. Do not feel bad if you are confused by this. It is a confusing thing. Look at all that work and we have done there. There is a lot of it. Come speak to me if you need extra assistance. It's a tricky topic. All right, and with that, I'm going to leave. I'm not going to lie. These were hard videos to make because I had to be so precise in my language and I had to re-record them many, many times. But hopefully you found them useful. Goodbye.